These notes are about the characteristics of a quadratic function, specifically the quadratic graph, which is called a parabola. I'm going to talk about some of these characteristics that are on the notes and then give you some examples on how to find them on a graph, and all the answer keys are loaded for you on my blog. So I'm going to be going between two screens, this notes page here and some examples. This notes page is found on page 9, and then I'm going to be working on pages 10 through 16. The first thing we're going to talk about is the domain and the range. We've talked about both of these when we talked about linear functions. They have the same characteristics. So domain, we're still talking about the x-axis. Remember, your x-axis moves from left to right, and it will always be negative infinity to positive infinity when our graphs have arrows at the end. The y-values is what's going to change, that range. We're always going to look from bottom to top. So let's look at some examples here. These examples are found on page 10. So your domain, those are x values. We read them from left to right. Okay, that's the way our x-axis goes. When we read from left to right, this arrow continues to loop forward. So we're talking about every possible x value. Every possible x value is represented by negative infinity to positive infinity. Your range is from bottom to top. So I'm going to look at the lowest y value on the bottom of my graph, and I'm going to move up to the top of my graph to see where that's headed. Well, the lowest y value on the bottom is at -4. And we're going to put that inside brackets because that's included. That point is on my graph. And these arrows at the top are going to go on forever, and those y values are only going to get more and more positive. Let's look at another example. I'm going to move down to number 4, actually. So from left to right is how we read our domain. Those are our x values, and they'll always be from negative infinity to positive infinity. Again, for our range, we'll start at the bottom and work our way to the top. So my lowest y value is a -1, and these arrows at the top reach positive infinity. The two examples I just did are when your graph is opened up, when your parabola is opened up. Well, let's look at some examples when they're opened down. My domain is still going to be from negative infinity to positive infinity. My range is going still from the bottom to the top. But now at the bottom, I see these arrows. These arrows are going to continue to point downwards, and those y values are going to get more and more negative. So this time we're going to start with negative infinity, and we're going to climb our way up to the top of our graph here. That has a y value of 4. Let's look at number 3. Again, my domain is always going to be negative infinity to positive infinity. My range starts at the bottom of my graph and works its way up to the top. At the bottom, I see those arrows, so that's going to be negative infinity. And at the top, that y value, that highest y value, is 1. And we'll put it in brackets. I'm going to encourage you to stop this video and practice the rest of the domain and range and check the answers on the blog. Back on the notes page, let's talk about x and y intercepts here. X and y intercepts haven't changed. The only difference is with quadratics, when we look at that graph, that parabola, I can have up to 2 x-intercepts. And remember, we talked about x-intercepts also having the name roots, solutions, and zeros. Our y-intercept is still where it crosses the y-axis. So let's look at page 11 and just do a couple of examples. When we write down zeros, zeros are x-intercepts. My x-intercepts are these points, -5, 0, and -1, 0. But when we write down the zeros, we'll write them down very similarly to how we wrote them when we found the solutions. You can list them -5 and -1. Or you can put them in a bracket. That bracket tells us that we're really talking about those set of x values. Again, your y-intercept is where it crosses the y-axis. That point here is at 0, 5. Let's do another example. Again, x-intercepts are where they cross the x-axis. Those are ordered pairs, so we'll list them as such. Zeros, that's 2 and 6, and I'm going to put them in brackets to remind myself I'm just talking about those set of x values. Now, your y-intercept is where it crosses the y-axis, but in this image we can't tell. So if you're only given the graph, it's okay to write not shown. And that's an appropriate answer. So again, I encourage you to stop the video, finish these examples, and check your answers on the block. Okay, the next characteristics that I give you examples of on page 12 are going to be 3 things: your vertex, your axis of symmetry, and a maximum and a minimum. Well, your vertex is the highest and the lowest points found on your parabola, and it's always going to be the point that's in the middle. The axis of symmetry is an imaginary line that cuts your parabola in half. When it cuts it in half, it's a vertical line, and we know that vertical lines are written as x equals. So it's going to be x equals that x value of our vertex. Then when we talk about maximum and minimums here, that's our highest point, maximum, or the lowest point, our minimum. If I ask you for the maximum or the minimum value, I'm asking you for the y value of the vertex. Anytime I say maximum point, minimum point, then I'm going to ask you for that full ordered pair. So let's look at page 12 for some examples. So here is my vertex. It's that point in the middle of my graph. That's an ordered pair of -3, -4. My axis of symmetry, I will always draw in just so I know where it's at. It's this imaginary line that cuts my parabola into 2 equal pieces, 2 symmetric pieces. That's going to be x equals my x value, my vertex, -3. Extrema is just another name for maximum or minimum. Looking at this point here, that's a low point. That means I have a minimum. And that minimum value is at the y value of my vertex. So that's at -4. Let's continue on with some more examples. Example 2, here's my vertex. So I'm going to write that ordered pair as 4, 4. My axis of symmetry is the imaginary line that cuts this parabola in half. Vertical lines are represented by x equals, and it's x equals the x value of my vertex. In this case, I have a reflection. When my graph is reflected, I now have a maximum. I have a highest point. And that maximum value is at 4, the y value of my vertex. Another example, number 3. Here's my vertex, the highest point on my graph. That ordered pair is at 3, 1. I can fill in my axis of symmetry here. That's at x equals 3. Again, I have a highest point. That's called a maximum. And that maximum value is at the y value of my vertex, 1. Again, I encourage you to practice identifying these characteristics by pausing this video and checking your answers on the block. The next set of characteristics we'll talk about on page 13 is an interval of increase and decrease. Now I've underlined the word intervals because they're no longer ordered pairs. I'm talking about a set of numbers, a grouping of numbers, an interval. The intervals we talk about are going to be x values. Increase and decreasing are only talking about the x values. An interval of increase is talking about the positive slopes, or the part of my parabola that looks like it has a positive slope. Interval of decrease, it's talking about a negative slope. The part of my parabola that looks like it's falling. So let's look at page 13 and look at some examples. To do this, I'm going to draw in my axis of symmetry. When I draw in this axis of symmetry, it allows me to look at my parabola in halves. So if I'm looking for a positive slope, that's going to be on the right-hand side. I start at the x value of my vertex, that's a -3, and I'm going to be climbing up to this arrow. This arrow crosses over in some positive x value territory, so I'm going to put positive infinity. That means the left-hand side of my graph is decreasing from left to right. It's falling towards my vertex. This arrow is in negative x value territory. So we start in some negatives, and we're going to fall towards the x value of my vertex, which is -3. Let's do another example when my parabola is opened up. Again, I'm going to cut my parabola in half using my axis of symmetry. On the right-hand side, I have a positive slope. I start at the x value of my vertex, which is 1. And this arrow is in positive x value territory. That means the left-hand side of my graph is falling. So we start with negative x values, and we fall towards the x value of my vertex, which is 1. When my graph has a reflection, it's going to change just a little bit. I'm going to put my axis of symmetry in so I can see. Now looking at the left and the right-hand side, my left-hand side is climbing up towards my vertex. That's the positive slope. So that arrow is starting in negative x value territory, and it's going to climb up to the x value of my vertex, which is 4. Once I get to that x value, I'm falling back down. So I'm starting at 4, and I'm going to fall towards this positive x value space. Again, practice these and check your answers on the block. End behavior and rate of change, also known as slope, are our last two characteristics. The one that's going to be played on this video is end behavior. Remember, we're asking ourselves, when x is negative, what is y doing? Or when x is positive, what is y doing? So we have two cases. Our parabola could be opened up, or it could be opened down. When it's opened up, both of those arrows are headed to positive y values. So both end behaviors will be positive. Similarly, when my parabola is opened down, both of those arrows are headed to negative x values. So negative y values. So both of those end behaviors will be negative. But let's look at some examples here. So my x values are negative. Well, here where my x values are negative, but my parabola is opened up. Since it's opened up, it's pointing towards these positive values. Similarly, with these positive x values, this arrow is still pointed up, so it's going to be a positive infinity. When my parabola is opened down, here's my negative x values, and that's where that arrow is headed towards. But as it continues to get negative, so do those y values. Same when my x values are positive. Again, take some time to practice this and check your answers on the block.